You know, the agricultural products industry has this massive, completely hidden liability: water. Whether you're milling grain, processing vegetables, or refining consumable oils, water is quite literally the lifeblood of your operations. And that total reliance, it makes water management an absolutely critical financial and operational risk.
So, before we even touch the technical reporting, we have to ask the fundamental question of how investors and stakeholders actually see the hidden water risks buried deep within these massive, complex supply chains. I mean, how do you quantify something as fluid as water risk? Well, the Sustainability Accounting Standards Board, or SASB, actually has a really fascinating data-driven framework to quantify this exact risk. Let's dive in and break down exactly how it works.
To really grasp this, we're going to walk through 5 key areas today: the water management challenge, measuring withdrawal and consumption, assessing high water stress, tracking regulatory noncompliance, and finally, why these metrics actually matter.
All right, let's kick things off with Section 1, the Water Management Challenge, looking specifically at the operational and financial risks of water.
When you look at the real-world consequences here, it is genuinely eye-opening. We are not just talking about a bad crop year, you know? We're talking about increased capital expenditures to somehow secure new water sources, extreme volatility in operating costs, and even direct competition with local municipalities. Just imagine the stakeholder backlash if a giant agricultural processor is competing for the exact same scarce water supply as a local town. It's a massive risk for sure.
Moving right along to Section 2, measuring withdrawal and consumption. This is really the what of water usage. Okay, so notice the huge distinction here. Water withdrawn is simply the total intake. It's what's being pulled from rivers, groundwater, collected rainwater, or local municipal utilities. But water consumed, that is very specific. It means water evaporating during cooling, getting permanently absorbed right into the food product itself, or being discharged into a completely different catchment area. Essentially, consumed water is water that literally never returns to its original source. Now, it's actually fascinating to see how strict the math gets here. Without a specific local legal definition to fall back on, SASB draws a really hard line. Freshwater must have less than 1,000 parts per million of dissolved solids. That is a standardized threshold that prevents companies from, well, muddying the waters on what type of resources they're actually depleting.
Let's pivot to Section 3, assessing high water stress, or the where of water usage.
To keep everyone on the same page, companies map their operations against the World Resources Institute's aqueduct tool. This mathematically defines what we call baseline water stress. So if an area uses between 40 and 80% of its available renewable water supply, it's classified as having high stress. But if it uses over 80%, wow, that's classified as extremely high stress. SASB requires companies to pinpoint exactly how much water is vanishing into these high-risk zones. And here's the thing, the risk absolutely doesn't stop at the factory door. Under the ingredient sourcing topic, companies actually have to measure the water stress exposure of their entire supply chain. Agricultural companies buy massive amounts of raw commodities from external growers, right? And the standard demands total transparency on whether those purchased ingredients are secretly draining highly stressed regions.
So how do they figure this out? It turns into this really fascinating 3-step calculation to find the exact percentage of products sourced from stressed regions. First, you map your Tier 1 suppliers against that WRI aqueduct tool. Second, you take the actual monetary cost of the products purchased from those high or extremely high stress regions. And third, you divide that by the total cost of all Tier 1 agricultural products. Notice that this is entirely based on cost, not volume. It literally reveals exactly how much of a company's purchasing power is directly tied to water scarcity.
Next up, Section 4, tracking regulatory non-compliance. Let's look at the how of water rules.
It is incredibly important to note that this metric for non-compliance incidents strictly looks at events that result in formal enforcement actions. We're not talking about a polite little warning letter here. We are talking about formal governmental actions like administrative penalty orders or judicial actions that address a clear violation of water quantity or quality laws. If a facility discharges a hazardous substance and gets formally penalized, boom, that goes on the record.
Notice how these violations are categorized so there are basically no loopholes. For continuous discharges flowing out constantly, regulators usually look at exceedances in daily, weekly, or monthly averages. For non-continuous or batch discharges, violations are measured by frequency, total mass, or maximum concentration. The standard makes it crystal clear.
Whether you're trickling pollutants over an entire month or dumping them all on a Tuesday afternoon, if a regulator steps in, it goes on the official record.
And finally, Section 5, why these metrics matter. It's all about painting a comprehensive risk profile.
This is where the data actually becomes actionable. You know, it's so easy to make vague sustainability promises, but when a company is forced to admit that 30% of its supply chain cost is locked in a high-stress region, well, that forces real innovation. We're talking about implementing closed-loop recycling systems, completely diversifying the supply chain away from drought zones, or rapidly developing drought-tolerant crop varieties. These metrics take fluffy ideas and transform them into trackable, concrete business strategies.
To wrap up this explainer, I want to leave you with this. The next time you pull a bag of flour or a bottle of cooking oil off the grocery shelf, ask yourself, what is the true, hidden cost of what's inside? Behind every single agricultural product is a complex, largely invisible web of water stress and regulatory compliance. These SASB metrics, they finally make that invisible footprint visible.